welcome to the November 2021 meetup. It's good to have everyone here. Still virtual, obviously, as we're all tuning in from our computers. One day we'll see each other in person, and we're actually starting to work on that, folks. I'll cover the meetups on a little bit. First, we'll start with a normal routine. I'll talk about how we're hopefully going to go back to in person eventually. So first up, jobs. I always like to start the meetup by saying who's hiring. Now, we can't have everyone jump up and say, you're hiring, because actually none of you can actually get on camera right now. So if you go to the NYHackR Slack, which is nyhackr.slack.com, and if you want to join, there's a link at nyhackr.org/slack.html. We'll post it in the chat. You can go there. There's a job postings channel. In there, post your job. We have all sorts of people who've gotten jobs from the meetup, both back in the before times and now through that channel. So please hop in there and post a job and look for a job. Since I am on screen, I get to say my company, we are hiring both part-time and full-time for data scientists, for Shiny developers, for Linux sysadmins, for data scientists, and account executives. So we're looking for all these roles in a flexible arrangement, remote, in-person, full-time, part-time. Let me know. And that's one of the benefits of being on camera. I get to tell you all that. So if you want a job, go to job postings on our Slack, and Nicole just posted them in the chat so you can get to it. There might have been a problem earlier with if you're not already a member of the Slack, I know a lot of you are, but if you're not a member, there was a problem earlier, but I think we resolved it, so that link should work. As is tradition at the meetup, going strong for over a decade now, I got pizza. So we do the cheese lock test, holding them nicely. The char test, see the sort of the bubbling since it was cooked in a pan. So you have the little bubbling, I guess the inverse bubbling. This is from Village Square Pizza. They have round slices too, but they specialize in the square slices, as the name implies, Village Square Pizza. I'm thoroughly enjoying this. I just had a vodka slice earlier, and it was amazing. So anyone, let me know where you got your pizza or other inferior food product from. Let me know in the chats, and let's see what you're eating. I always enjoy either here in the chat or in the Slack chat. Let me know. I always enjoy seeing where people are getting their food from. In fact, let me open up. I hear it's clicking a lot. If I could find it, where did my Slack go? Oh, David Espinola is telling us that he had Domino's. Okay, yeah, that happened. That happens. Oh, Brandon, you made homemade pizza. That's really cool. And folks, send pictures of your pizza. You all saw my pizza. Let's see your pizza. Send up pictures if you can. I'd love to see this. What else we got here? All right. I see JD has something coming. Let's see what you're saying.
Just recounting.
Chipotle.
Doing what I can in suburbia here.
I guess so. All right, fine. We'll let that pass. You are speaking tonight. You'll survive. So while we wait to see everyone's pizza photos, if you have them, we want to thank EcoHealth Alliance for providing the Zoom link for us. And I believe Noam from EcoHealth Alliance has something like to share with us.
Hey everyone, good to see everyone. It's great to see JD. Haven't seen since the long ago many meat space meetups. Normally I'm the silent partner back here as EcoHealth works with New York Art to sponsor the virtual meetups as we have since last April. I just wanted to jump in my capacity as lead for software review for the ROpenSci organization, because we have a meetup in a few weeks that I thought this group would be really interested in. I, Karthik Ram, Mael Saman, and Arfon Smith, who's product manager at GitHub for data and the editor of the Journal of Open Source Software, are hosting a community call where we're going to talk about our new infrastructure for automated package checking, editorial peer review, and sort of chat-based DevOps that we've developed together, working from the GitHub sort of ChatOps DevOps bot, Hubot, developing something for the Journal of Open Source Software, and now ROpenSci, which is our new sort of interactive GitHub package checking system. And I thought that would be something that this group would be really interested in. So I'm going to put a link for that in the chat right here, as well as in the Zoom chat for those who don't make it over. We think it'd be something that this group would be really interested in. And we're really proud of this because it's something that we've built for our use, but is an open source tool that you'll be able to start for your own repositories, your own internal groups that might be interested in this kind of peer review system for quality control, which has been something we've been pushing for a long time. So thanks for the chance to talk, Jared, and looking forward to your talk, JD.
Great. Thank you, Noam, and I hope everyone enjoys that the meetup if you go to it. Our OpenSci is pretty great. I mean, Noam is awesome by himself, just alone. That's great. Then our OpenSci is also really awesome to do lots of great stuff for the community. So I hope everyone really enjoys going to that. It should be a good time. I do see John Keane is making calzones, and I'm a big fan of the racket pizza, half pizza, half calzone. So thank you, John, for including us in your journey tonight. Next month, we have, in addition to the monthly meetup, which I'll get to, we have the Government and Public Sector R Conference. This is now the 4th year. We've had the New York R Conference going for a while. This is the public sector conference where it's about using R and friends. There'll be R, Python, SQL, other tools, or just general statistics and data for either government use or public sector. We have data journalists coming. We have people from West Point. We have people from the Air Force. We have people from different branches of government, both federal and local. It's really going to be a really great time. It's like a more focused version of the R conference. And we just added a few new speakers in the past few days. Some of them are Cesare Podkul from ProPublica, Asama Toomey from Pursue Health, but also the Big Data Bowl winner, and David Shore from Blue something consulting. I forgot the name of the company. Sorry, David. But David Shore, you may have heard of him from a lot of his political analysis. So it's going to be a really great time. That's just some of our speakers. We have a few more we're going to be adding. We have a few more that have been there for a while on the list. Come join if you want to join. These conferences we put on are supposed to be essentially this meetup, but for 2 full days, just full days of learning. So since it's for members of the meetup, you can use code NYHackR to get 20% off your tickets. You go to rstats.ai, and in there you can find information about the conference. You can also find videos of all the past 7 years up there, and you can get tickets. And remember, code NYHackR for 20% off. And our very own JD speaking tonight has spoken at least one of the conferences, if not more. And he's also a repeat speaker here. In addition to the actual talks, we have workshops so the conference, oh, by the way, the conference is December 9th and 10th. On December 8th, we have 2 workshops. John Hirsch is giving machine learning for public policy, and Alex Bogosian is giving a talk about understanding climate change data. So both of those should be really great workshops. You want to learn your skills. They're full day workshops the day before the conference where you really get to get hands-on practical skills. They're going to be really cool workshops. I am always debating which one I should go to, but I've already taken John's workshop, so I'm going to go to Alex's because I haven't seen that yet. John's is going to be awesome too if you haven't taken it. Even if you have, it'll probably be good. So meetups we have coming up. Next month, before the conference, either the week before or a few days before, we have to get the exact schedule locked down. We have the intimidable Max Kuhn giving a talk. We are always excited. Yeah, thank you. We are always excited when Max Kuhn gives a talk either at our conference or at the meetups. He's done both. He's always awesome and a lot of fun. You're going to learn a lot and you're going to have fun. I can't say how great that's going to be. So the December meetup will be Max Kuhn. The exact date will be announced in the next few days as soon as he texts me back. Because I threatened him that I was going to announce the exact date today, but I figured I'd let him choose the date. Then in January, we have ZJ Dai talking about disk.frame. For those of you that don't know, this is a package that allows you to use dplyr and data table operations on a file on disk, like a CSV or a collection of CSVs. It's gonna be really awesome. I've used diskframe a little bit in the past. It was really cool, and I'm interested in seeing, so now Arrow does something very similar. I see John is here tonight, John Keane. I wanna see how they compare against each other. We had Wes McKinney and I think John or Neil or both spoke recently at the conference about Arrow. Now we have a disk frame talk. It's going to be cool to see how these things are going. I'm really excited about this. Then in February, we have Hans Mulessen. And Hans, if you're here and I mispronounce your name, I apologize. We have Hans Mulessen from DuckDB. Going to be talking about using that in general, and I think with R maybe. I'm not sure it's going to include R or not, or it would just be about DuckDB. Those of you that don't know, DuckDB is a very popular in-memory database, sort of like SQLite, but much more for analytics. And it uses Arrow as a backend, and you can run dplyr commands against this database. So I'm really
this presentation I'm giving today was just almost a DuckDB because I've been experimenting with DuckDB and Arrow, and I just almost threw all this away and gave a presentation about that, but I didn't have time to actually go through the R integration. But it's such a neat, interesting package. It doesn't quite do what I think it's supposed to on S3, but it's getting there. It's very early. Highly recommend it. It's worth knowing about.
Nice. Perfect. There you go. So folks, come in February. Hans is one of the creators of DuckDB. So come. And it all happened. He posted something on Twitter. He responding to an R question. So I messaged him, hey, give a talk about it. And he said, yes, that's the way this works, right? Post something cool, or just come ask me. You want to give a talk, be brave. Say, hey, I want to give a talk, right? So then, hopefully in March, we're hoping to plan to make a return to in-person. We have 0 details now. We're just trying to figure out which venues are comfortable hosting us. So by the way, if you have a venue or an office that can hold about 100 people or more in New York City, let me know if you want to be a host, because we can't just rely on one venue. These things are a large thing to do. So we have multiple venues. In the past, we've done Rise New York on 23rd Street. We've done New York Presbyterian. We have done, I can't remember that incubator we used to work out of that on 19th Street, and eBay's used to host us. AOL hosted us, Columbia and NYU, 2 Sigma. Sure, there's a whole bunch of companies I'm missing now. So if you would like to host us, let me know. We are hoping to be back in person in March. We'll be coming with those details soon, but we've got to coordinate with A, making sure it's safe for everyone, B, making sure everyone's comfortable, and C, finding a venue that's willing to let 100 people come into their office for a meetup. And that's where things get tricky. So we're hoping if we can't do it in person, it'll be fully virtual. If we are lucky enough to do it in person, it will be both in person and on Zoom. Before the pandemic, we recorded and posted it to YouTube, but now we're hopefully going to have it live at the same time. We will hopefully get to that soon, and fingers crossed, folks, in March will be when we get back to it. And we can't do it before then because the 2 speakers are not from New York, so we can't do it until then. JD, you're going to say?
I was going to say, Rajan asked in the chat about the continuing the virtual option, and I think it's fantastic. He's watching from Chicago, which is great. I had some of my colleagues in Dublin, Ireland, were asking about wanting to participate in this today. It's getting kind of late there. I suspect they won't be here.
There's someone from Austria saying they're here. It's 1 a.m. Right?
Yeah.
Thank you for being here, and we will continue to do it virtually. So rest assured, everybody, there will still be this virtual component live as it's happening now that we have the technology. The technology didn't really, before the pandemic, we had the technology for the video, but not the audio. The audio didn't work. But now that we have this, oh, we have someone from New Zealand. Wow, you might win the record. Well, congratulations on winning that one. And the home of R. So, and I will fully say, when I was at the University of Auckland, they took me to the room, Paul Markham took me to the room where R was invented, and I took a selfie of that room because I was so excited to be in the room where R was invented. So I'm very happy about that. So yes, we will continue the virtual component, and we'll try to make it as good and available for everyone around the world to do, because I know we get people from all over. We have someone from Florida. Yeah, everyone let me know where you're coming. Oh yeah, Austria is home of crayon. So that's pretty cool. You know, home of crayon coming. All right. One last announcement, and we want to get into our excellent talk. Oh, Australia. Ooh, Australia and New Zealand. I think New Zealand wins for distance, but I'll let you two fight in the comments because I'm not getting involved in that historic battle. Hope everyone's excited for a good time. JD is someone who has, long before I ever met him in person, I knew who he was. I remember when we had this at AOL, someone just mentioned his name in a meetup and everyone erupted into applause for the stuff he was doing. This is back then, I think, your AWS package or whatever it was called originally.
Yes, Segway.
Segway, yes, it was Segway. Yes.
Yeah.
He's, hi, come on in. And we have a visitor, our mascot. Hi, do you want me to open that for you?
Did you get started yet?
Yes, we're starting right now, actually. So we have visitors.
We're live.
So everyone, JD's been speaking at the conferences, at the meetups, been active on Twitter, and he's just amazing. So I will open it for you. Everyone, please welcome JD. Call clap for him.
Thank you so much, Jared. Appreciate it. So fun to be here. Good to talk to you guys from Raleigh, North Carolina, which is where my office is. I live in Richmond, Virginia. Let's see. I guess I should share my screen since I'm going to present here. Let me do that. All right, we should have screen action now. And this whole speaking into a void, not being able to at least see faces of people when I talk, like I really don't like this, because at least at work, I got faces that make me know I've been going on too long, but I don't have that here. So I'll just go on forever. So this presentation was kind of spun out of Jared asked me, hey, you got anything to share? You've always up to something interesting. I've seen you shit posting some stuff on Twitter. And I'm like, yeah, I got some stuff, but it's not exactly like I'm going to walk through a package, or I don't really have a bunch of R code. I'm a live demo. I've been thinking about stuff, and I've been working with a team to test some things. And he's like, can you make a presentation out of it? And I'm like, yeah, this is normally the sort of stuff we talk about at the bar, but hey, we can't do that. So this is sort of the equivalent of that. Now, I know these slides are going to be posted, so I always include this slide that said, these don't stand alone, go watch the video, and we'll fill that in later. Now, who am I? I'm co-author of the R Cookbook, second edition with Paul Teeter. You may know me for my prolific shit posting on Twitter about data analytics, parenting, whatever. And you may also, if you signed up for the Slack room here, you may have seen me on this image back from the New York R conference when we did things live and in person. All right, now I wish I could like poll easy, but so maybe comment in the Slack. Or let's see, can I open the chat? Okay, I can see chat now as well. Has anybody seen like this cat fight that's been going on like in the blogs back and forth between Snowflake and Databricks? Is this a thing people have been exposed to? Some of us that are close to the data circles have seen this, and it's basically the gist of it. And I do not use either product, and I have no connection to either team, so I don't have a team here. But the gist of it is Snowflake responded to some post Databricks and said they weren't doing their benchmarking right, and then Databricks comes back and says, well, Snowflake did some pre-processing of the data before they ran the benchmarks, and that's not cool. And so they're back and forth. And I got to tell you, I 100% don't care at some level. Like I just couldn't care any less about two vendors pissing all over each other's shoes. What's interesting here, though, is that they're obsessing over metrics. And part of what I want to talk about is when it comes to cloud sort of junk, and especially the stuff that we do, we being the people who come to like our meetups, we are not typically building data warehouses for the entire organization, right? And this is really what the whole Snowflake Databricks gripe is about, is a data warehouse benchmark. We're usually trying to do some workflow that isn't a bog standard reporting data warehouse. And so what that means is metrics, which are often bullshit to begin with, are extra bullshit when it comes to the things we care about, because it just doesn't capture what we want. And even when we sit down, being smart people who are used to thinking analytically, when it comes to time for us to sit down with a tool and evaluate them, we often make this mistake that can be called attribute substitution, surrogation, or I love it because I'm an economist, street lamp analytics, right? Street lamp analytics is we search for our keys, not where we drop them, but we search them where underneath the street lamp, because that's where the light is. What we care about and is one thing, but what we can easily measure attracts us because we're analytical people. And if we can make a metric, and especially if we can carry that metric out to 4 stupid, meaningless decimal points, we're going to do that. And then we're going to rank them, right? And so we got to be careful not to do that with our business metrics, and also not do that when we're picking tooling for what we're doing. So I'm going to tell some stories about looking at tooling and thinking about like what tools to use for certain type of workflows. Whoops, I didn't mean to advance. I need to real quick say a bunch of this is done in the context of my employment at Renaissance-Re, where I'm a VP risk management. The stock trades down every time my name's associated with the company. So I just want to acknowledge that I work there. I'm working with a bunch of smart people who are smarter than me, and they've actually probably done all the work. And only thing that I contributed was anything that's wrong in this presentation. And the conclusions I'm drawing here are absolutely mine. If you were to talk to people in IT or other parts of the organization who worked with me, they probably have very different conclusions. So it's my opinion, not the official opinion of where I work. and definitely not even the opinion of my coworkers who I work closely with. So anyway, with that said, you know, I was chatting some of this up in the process of prolific shit posting, and you know, Jackie and Brian Fannin both had this point of view that really is going to be foreshadowing for a little bit of what I talk about. You know, they both mentioned developer time, developer salaries, you know, the cost of developers, and often in our systems and what we do, those costs completely dwarf what we're paying for computers, hardware, compute time, storage in S3, runtime, but they end up in a different budget area. And so we don't see that when we start measuring stuff. And so I feel like it's easy as we think about these tooling to not appropriately account for how long is it going to take to get our workflow? How many developers hours am I going to have to spend, either my time or a professional developer who does it right? To how long is it going to take for them to get something into production to do something that I'm trying to do. Now, if I'm trying to do a one-off, it's probably all my time. If it's something that's going to work regularly at my work, probably going to need other people involved, right? So we can't forget that that's probably the most meaningful cost. So this whole thing's going to be in a context of a story, and I've spoken out loud about this, right? I do a lot of learning out loud, both on Twitter and in person, but in Twitter, sort of it gets captured for posterity, so I can go back. And this is about 6 months ago. You know, I raised this question of I got 5 billion records in a table, and then I got 100,000 records in another table. So it's a many-to-many join. I want to join them together and get 25 billion records. It's all in S3 Parquet files. And what tools should I consider, right? And I mentioned Sparkdask and Dremio because these are tools I'm interested in. Got a bunch of great responses. This is all, I don't delete my past tweets, so you can go find this and see what other people responded. Very thought-provoking. And I got a bunch of good ideas. And so like I'm gonna continue the story with, you know, I was like, let me go test this. And multiple people that I think highly of basically said, this is a Spark problem, just use Sparks, don't overthink this. So I'm like, okay. So I went on Amazon, stood up a Spark cluster in Elastic MapReduce, and I made dummy data, because that's what we do, right? We start with some dummy data. I created dummy data that was, you know, some data frames relatively the size, the right size. And I did a simplified version of the logic that I thought contained like the meat of the logic, but not everything. And I tried it on Spark and it ran in 45 seconds. And I was like, holy crap, this is so easy. Like that, they're right. Just use Spark and it's really trivial. And so I was like, well, I've had enough life experience that I know I should test with real data, because, you know, there's probably some, I know it isn't shaped exactly like the real data is. So I went and got real data. Data was the same number of rows as the test data, same logic. And the actual runtime was well over 30 minutes. It was like 45 minutes, an hour, depending on the cluster size. And so I immediately was like, what in the hell? But I understood my data. So I sort of quickly figured out what the problem is. And I was trying to figure out how to communicate this to you all. And here's the best summary of why my real data was not like my test data. We had 7,000 groups that I was, you know, grouping by coming into this, and 5 billion records. Our top 13 groups, so that's 0.2%, were 40% of all the records. So they were 2 billion records just in those 13 out of 7,000 groups. In the vernacular, this would be high class imbalance. So if each of those were classes, it's going to be highly imbalanced. And it's kind of when I learned the term high class imbalance that I realized I had gone from, I thought I was just going to have an easy button, to all of a sudden I get a very rich lexicon of crap, that words that I have never heard of, just a body of knowledge that I haven't been exposed to in these large data terms. And as much as kind of like all the vendor junk and people's success stories in their blogs or whatever kind of make you think, all this stuff sort of just works. Our observation was, as our problem got big and a little bit complex because of these uneven groupings, the person who was using it needs to rationalize about what's going on underneath the abstraction. So we want it to not have to rationalize about what's going on underneath the abstraction. I want these tooling to just act like it's a data frame that has, 60 billion records, and I can just work on it like a data frame. The reality is, at some point, you can do that for some size and some shape of problems. Our problem kept hitting the boundaries. The only tool that I looked at in the process of trying to figure this out, where I didn't really have to rationalize about what's going on the individual nodes, was Dremio. And that's because Dremio is really designed to be an appliance, way more than the other platforms I looked at. So anyway, but I'll talk more about that. I'm getting ahead of myself. So there's a few, and I'm not going to spend the whole presentation introducing you to the language of stuff you should know about with these big distributed data structures and systems, but a few things in this rich lexicon that you're going to have to need to know about pretty fast, in my opinion, is classes. That's the thing I just talked about with the class imbalance. So like anything if you think in SQL terms, anything you group by, or anything you join by, those matter because some operations will require or may work best if an entire class is on one of your worker nodes. So since I have 13 classes out of 7,000 that are huge, if I have to put all of those on one worker node, that's a bunch of data transfer. And if 2 of those end up on one worker node, I'm probably overflowing RAM. And I may be overflowing RAM with just one of those classes if it's one of the biggest ones. So I have to start, once again, rationalizing about what's going on underneath the abstraction, which is a lot more work. So the other thing you have to know about, in addition to classes, is partitions. And what's wonderful is partitions has different meanings that mean slightly different thing. They mean generally the same thing, and that is how the data is like chunked up. But if you can write a partitioned Parquet file out, and Arrow has a way, the Arrow library has a way for doing this. And if you write it out, it will use, and I just recently learned this is called the Hive key value naming convention, where it has a key and a value and it names a directory this way. And every one of those directories is a partition. And those are great because it makes for faster reads, because if you just want to read one partition, it can go directly to that folder with that partition on it, read only that, and it doesn't even scan the rest of the data or anything. Okay, those are kind of nifty. That's a type of partitioning. There's also the type of partitioning, say with Spark, where when you read it into the system, how is it spreading those across all the workers? Now, in that type partitioning, every partition, it does not break the data into every partition. It may do windows of partitions across the nodes. So they don't always mean exactly the same thing, but they generally mean how's it being chunked up. And then shuffle. The term shuffle meaning to transfer data between the nodes in a distributed system. And shuffle is the costliest in terms of runtime, and IO is the costliest thing we do. So you have to kind of understand what causes shuffles and how to minimize shuffles, and think about how to organize your data in such a way to make that less likely. So, okay, you can see pretty quickly we're having to think about this stuff and not just hitting the easy button. Another aspect of this that I quickly discovered is the big file, the tension between the big file problem and the small file problem. Big and small are both problems. So there's this Goldilocks size for your files that you read in that's in the middle. The big file problem is many of these systems have one reader thread per file, per input file. So that means if you had 6 gigs in one file, you get one reader thread to read the whole thing. And that kind of sucks. And the flip side of that, the opposite, is the small file problem. So if you have, say, 7,000 groups, like I do, and you break your data into 7,000 individual files coming in, whatever system you're reading into pops all of those open and reads the headers, and it parses calls the directory tree and all this garbage, and all that takes forever. So you get a bunch of, like, when it comes time to read, if you have 100 nodes, you get 100, maybe 100 reader threads or more. You may have multiple threads per node, which is great. You're doing a bunch of stuff in parallel, but it's got to traverse all those files and directories. So when you have small files, those produce an inefficiency as well. So you got this tension between these optimal file size problem. All right, so here's my big data testing philosophy that I have sort of begun to form as I've been wrestling with this problem. Wrestling sounds like I'm in Raleigh, North Carolina. Gonna go wrestling. When testing architecture, use data that's really the same size and shape of your problem, right? And that was my mistake at the beginning. I conflated row count with shape, like row count and columns. That's not really the shape, right? Because the real shape would include not just the row count and the number of records, but also the amount of skew that's in those groups, how a few of the groups were really big. That's an example of like the real shape of the data, not just the dimensionality of the tabular data that's going in. I didn't appreciate that a few months ago until I ran up against it. The other thing that we're trying to always make sure that we do, and this may seem obvious to those of you who've done this, is you test an architecture with the real shape data, and then you test it with multiple X times that if you think the problem will grow. And like we think our problem will grow. So we looked at in which dimensions and in which ways might this grow. It may grow that we need to do this process I'm prototyping. We may need to do it multiple times a day. That's one type of growth. We may get more records in the data. That's a different kind of growth. And so we need to know, can we do it with larger files? Can we also do it multiple times at once? And some systems are better handling that than others. To answer Brandon Herr's question, because I caught it out of the corner of my eye, I actually really needed to process all of the data. I don't necessarily need to load it all at once. So it raises a good question. And I'll mention some of this in some problems we had with Athena when I get into this a little bit farther. So one of the things a developer came to me about a year ago, and he said, you don't know which platform you want to implement this workflow on, right? And I'm like, right. And he's like, okay, I think you should do it here. And I think that's what we should build. And I'm like, whoa, you can't pick a platform before you've even like prototype. And he looked at me and he said, I can't build this on all of them. That's an awful lot of time to build on all of them. And I'm like, whoa, this is a false dichotomy. It's not pick one or build them all. How about we figure out which part of the problem is the hard part? And we try to implement just the hard part on multiple different platforms to understand how they behave with the hard part of our problem. And that was a little bit of a new way of thinking of it to him. It seemed really obvious to me. And so I think it's worth mentioning here that, you know, you've got to have this, I'm calling a minimum viable data flow. I mean, it's really minimum viable product, but I hate thinking about this thing as a product. It's really what's a data flow that gives me a meaningful answer that does the main steps I would want to do. And we take that and we shove just that through multiple architectures, even if we have to do it kind of manually. Like if I would not have my developer stand up the infrastructure as code bits to just test this, you know, one workflow. That's way too big of a heavy lift. Like do it more interactively or whatever the easy on-ramp for that platform is, and test the flow and profile it a little bit and understand the performance bottlenecks. So I'll give you an example. In my problem, I said I had this, what was it, like 5 billion, and I join it to 100,000, and then I do a bunch of aggregation. After we do a bunch of aggregation, we do a bunch of sorting. I thought when I was going into this problem that the sorting thing we did towards the end was gonna be slow. And I was not obsessed, I was anchored a little bit to that was gonna be the problem. And that's really where I was thinking about all kinds of ways we could speed that up. As soon as I started profiling this problem in Spark, I discovered that where I do that first join, the 5 billion to 100,000 to end up with 25 or 35 billion records, that join step is the bottleneck. it was more than half of the runtime, meaningfully more, like 2/3 or 3/4 of the runtime of the whole process as I had spiked it out. So I quickly learned, oh, this is really all about how do we make that very first step fast. And so then we could really focus on that. And so when we tested multiple platforms, we always tested that first, just to make sure we were doing that reasonable. And then we could test other bits. But we wouldn't have figured that out if we didn't do like a minimum viable data flow first. And one of the stories I tell, and I was on Dremio's Subsurface podcast relatively recently and got interviewed. And I talked a little bit about some of this. But one of the things I commented in there, and I will reiterate here, is when you go into building a meaningfully large, complicated workflow, what I discovered is I learned two things. I learned about things about my process that I didn't understand. And that's like me understanding that big join step is the hard part. And the other thing I learned was I learned tons about the tooling and what goes wrong and how it falls over and all of that. I think that's normal because most of us think we understand our problem and then we don't understand how our problem interacts with the systems we're trying to use. And so I think most of us will learn a lot there. So which platforms should one think about, right? I'm telling this all from my point of view, but I know folks are going to listen to this, think about what should I use? You got to start with your organizational constraints, right? If you're just an analyst all by yourself, you're freelancing, or it's a side project, you can choose anything under the sun. So you've got a very wide set of choices. I was trying to solve problems in the context of an organization. So I would be foolish if I didn't think about this in the context of organizational constraints. So our organization tends to have existing relationships with Dremio, with Amazon AWS. We also use Azure. What we don't use is much Google Compute. We've experimented with a few things, but we don't have much going on over there. And I looked at it, I think Google BigQuery looks interesting. I would like to test our problem on Google BigQuery, but I know I'm going to need to solve this problem ultimately in a production environment. And when I say we, I mean, I say me, I mean we as in the organization. So I didn't even profile it in BigQuery. I may consider that later as a novelty, but it doesn't fit in my organizational constraints to do it there. So the other thing is, lots of folks, and I think many of you listening are already thinking, he is going to tell me at the end of this, what's the one ring to rule them all? This great thing that he discovered and how it worked magically. That is the absolute wrong way to think about the problem. Think about roadmap, thus my roadmap, not what's the one easy button or magic solution that's going to solve all of my problems. That mindset helps a lot. The other thing that's important, and I talk about this, I use a lot of me, and I've caught myself a couple of times and said we. We joke a lot about teams, and together we can do the work of one. And how much it slows us down to work in teams. This workflow, I absolutely, no doubt in my mind, I understand the workflow better, and we got a better answer because we had people from the business, people who were consultants and specialists in individual platforms, and folks from my IT team working together to understand the problem and profile some tooling. I can't overstate how important that is. If IT had run off without involvement from the risk team, we would not have gotten as good answer. If the risk team had built this without input from IT and our consultants, we would not have gotten as good of an answer and understood the systems as well. It's just really super useful to get multiple perspectives. I call it the benevolent dictator problem. I love solutions that appeal to the exact way I understand a problem, right? That's my narcissism. And this is classic overfitting. I have a model. This is how I see the world. And when I go out and pick solutions, I pick them according to that model, which ends up with solutions that are overfit to my myopia. So it's work on teams, right? And get other people involved. Some of the people, in addition to my fellow employees, we've been working with Theorem out of Dublin, Ireland, and these guys are great. We had Owen and Mark Hodnett. Now, Mark's got an R connection. He wrote the R Deep Learning Essentials book with Pact. So I got to give him a holler out because we're at an R meetup. And Owen, despite his profile picture on Twitter, is not a leprechaun. And I was really disappointed to discover that. They have been great and tremendously helpful in understanding systems and how these web-based systems should and could be plumbed together. And they've taught me so much. Now, when I say a roadmap, here's an example. This was absolutely put together by me, and I threw it out to the guys, the other ones on the team, as a straw man for them to talk to me about it. This is an example of a roadmap of how I think about Dremio, Athena, Glue, Amazon EMR, and Dask. My sort of framework is, is SQL enough to solve my problem? Because right off the bat, if SQL is enough, I'm going to probably want to use Dremio or Athena under certain situations, because both of these are SQL engines sitting on top of Parquet files in S3. And nothing could be like more straightforward from an analyst point of view than interacting with Parquet files using in S3 using SQL. It's just super straightforward. But sometimes SQL is not enough. And if SQL is not enough, you got to actually do more code than that. Well, it pushes down and say, well, do I care about cluster latency? If I do, then I really should be looking at Amazon Glue. Now, you see here that Amazon Glue and EMR are both Spark. What's the difference? Glue is a hot cluster, so it's hot glue. By hot cluster, I mean it's up and running. So if I ask for 50 nodes on Glue, I get them in 8 seconds or something like that, under 10 seconds. But if I do that over on EMR, it's got to stand the nodes up. So that may take 5, 10 minutes, 15 minutes. And so if I'm just looking for things fast, it's hard to beat Amazon Glue. Now, the downside is Amazon Glue only get 2 worker types because they have hot node, AB, and Amazon have pools of these things up and running, and they don't want to have pools of every possible permutation. I said 2 worker types. I think there's actually 3. I kind of ignored the smallest type because it was a pain in my butt, and I just thought about the other 2. So anyway, I think it's actually 3. But anyway, there's a very limited number of worker types. EMR, you can stand up on absolutely any size that EC2 machines that they have available, but they take longer to stand up. Now, do you need tight Python integration? For those of you who work with Python, we work quite a bit with Python. Sometimes it would be very nice to have like Pandas data frame sharded out across lots of workers. That's exactly one of the things that Dask does. And we can stand up a Dask cluster using AWS Fargate, or we can stand up a Dask cluster using services from from vendors like Coiled. And we contracted with Coiled to help us with this POC and had a great experience working with them. They were super responsive, helped us understand how to stand up our cluster on their hardware. It was trivial. Well, their system it's Amazon's hardware. We found for our workflow, it's not quite the right tool. And also the Dask ecosystem is not as mature as the Spark ecosystem. And I think that we definitely have Dask on our radar of technologies I want to watch. And I also want to test out, more than just the data frame way of using Dask. So Dask can be used as data frame or as a handful of other ways. There's a lot of interesting things going on in the Dask ecosystem. It wasn't quite the right tool for our problem for a number of reasons. We've talked those over with Coiled. They've been very receptive and they have said, yes, okay, this is a problem. And as a matter of fact, we got 2 open feature, well, I don't know if they're feature requests or issues on Dask because of this profiling work that we did with them. That's a great outcome. Their product's going to be better. The Dask tool is going to be better than the open source version. And we're going to keep watching it and may use it for other things in the future. Other things we would consider is, do you need spot instances? How frequently are you going to run? And how much developer time can you or should you throw at the process? Because if you have lot of developer time, or you're willing to incur the fixed cost for a bunch of developer time up front, you may say, okay, I can get lower runtime, lower AWS costs by spending more developer time up front. So you got to trade off that fixed cost of developer time up front with the marginal cost of decreased runtime as you run these jobs. And so that's obviously the wild calculus there is how many times you can run this a day and over how many years in order to recoup your developer cost. So these are the sort of things about how we think about this. All right. So there's some unexpected constraints that we saw as we started thinking about these big data tooling. Things like how easy or hard for business domain experts to collaborate with the tooling. So if the tooling is very difficult for those of us, say like myself, who have a deep domain experience in the business, to collaborate and test logic with a professional developers, we're going to move slow. But if I can just write up examples in SQL and they can implement those in SQL, that makes a really fast feedback loop for how we get things done. So that's kind of not something I hear a lot of folks talking about is, well, how easy it is the tool for your developers to work closely with the business experts. Right now, part of it is we have really incredibly technical business users. Right? I'm a business user and I wrote an R book. So clearly maybe more technical than you might find in accounting. So we want to be in the guts of whatever it is. We're in because the nature of what we're doing, we need to be in there with our professional developers. And so how easy or how hard is that? Deployment and maintenance. So how hard is it to do changes in logic? How hard is it to deploy the solution if you're going to use it, say, productionist, where you're running it lots and lots, maybe daily or multiple times a day? And like one of the wild cards in all systems is complexity, right? Complexity has a cost. And it's really hard to value that appropriately. But the older I get, the more I value simple solutions because I have just paid the hidden penalty cost for complexity too much over my life. All right, since I know y'all ask, and I don't think I can give a presentation like this without some sort of indicative benchmarking, let me tell you this. All right, so what was our least expensive run when we profiled this job on everything? The least expensive run we did was on Amazon Athena. And the reason is the Athena pays only for the data you scan. So you can get an awful lot of compute pretty cheap. And I mean, I think it was like under $1 when some of the solutions we were throwing 30 or 40 bucks a run at, just to give you relative ballpark. Don't quote me on exactly those numbers, but orders of magnitude more on some platforms than on Amazon Athena. The downside of Athena is we had initially ruled out Amazon Athena because first time we tried to run our job on it, it literally just ran for an hour and then failed. And we're like, well, that doesn't work, and kind of gave up on it. And Mark, who I mentioned earlier with Theorem, and who I should know is a smart guy, right? Because he wrote a deep learning in our book. He was like, let me play a little bit with this Athena. I think we can make this work. And I'm like, whatever, knock yourself out, dude. And he went in there and he ran it in chunks. And he also knew you can run up to 20 queries in parallel. And so he ran 20 queries in parallel on chunks of data and was able to make our workflow work. And it was not the fastest runtime, but it was absolutely the cheapest. But it required more development time, right? Because he had to chunk it on the beginning. So trade-offs. The dev favorite, excuse me just one second, I need to clear my throat. The dev favorite was Amazon Glue. And by dev favorite, I mean one of the devs in the team was his favorite. And it was a commonly positive thought of tool because with Amazon Glue, you get a hot Spark cluster that's very easy to interact with. Not without nuance or quirks, though. We found there's multiple ways of relating to it, and they had kind of different performance, and we're not sure we understand that. There's some abstractions that they being Amazon have built on top of Spark that we're suspicious were slowing us down, but we're not 100% sure. So some questions there we'd like to understand better. What will we probably build our first gen of this workflow in? Dremio. Why will we do it? Because it's drop dead simple to implement with. We probably won't, well, we may or may not, I can't say we probably won't. We may or may not stay there long. We may change the workflow somewhere else, but we can take our quants and our developers and we can implement a solution right there and have it up and running really fast. And as we grow, we likely will want it out and onto a different platform. We may not be able to get the licensing terms we want with Dremio, but because we're just with Dremio doing SQL on top of S3, it's super easy to migrate it out of that environment if we think we need to later. So once again, it's a very reversible solution and it kind of fits right into our ecosystem. If you didn't have a Dremio, Dremio is our tooling we're using for data lake solutions already. So we had Dremio on-prem, right? And it's like, well, let's see if we can just use it for this other workflow. And we did. And so we will be profiling that. But this is kind of an R meetup, open data R. But what about R and Python? What is especially R? Think about these workflows as you know how in Unix or Linux we would like pipe CSVs between things, and CSV was the common language, and all of our tooling could be loosely coupled. If we use CSVs in between them, the new CSV is Parquet files, and the place to put them is S3 if you're in Amazon, right? So we can think about all of our workflows are these loosely coupled pieces with Parquet and S3 in between the chunks. So we may use Amazon Glue and then put the results there and then put Dremio on top of those results. And with Python and R, we can look at the S3 and interact with the resulting, Parquet files in S3 at any point along the way. We can also connect them to tools like Dremio using, JDBC, or other database connection methods to connect with them as if they are a data source, and then do all of the normal stuff that we do with data sources. And we can even, write SQL that creates new tables, and those new tables are just more Parquet files in S3. So we begin back, if we think about what are the roots of R, right? The roots of it is this easier to use interface around Fortran programs and have graphing, right? And be able to graph the output of these, Fortran science libraries. Well, we're still kind of there in that we're using R or Python as a little bit of orchestration and a little bit of like doing some reporting, grabbing a piece of data, and we're using, instead of, Fortran libraries behind it, it's maybe our cloud libraries behind it, and our data is remote instead of being on our local machine, but we're still leaning on what is useful in these tools, R and Python. Easy to write, the code is, it's easy to read, it's pretty output in terms of graphics, and we can do a bunch of quick analysis on it. All that's still in play, we just got it laying on top of different stuff in the background. So ecosystems, it's all about ecosystems. And this is, I'm just about wrapping up. I got 2 more slides. So Jared should be getting ready with questions. And there's 2 ways to think about the ecosystem. We look at the Apache Arrow project. They have one approach, right? There are Python libraries for Arrow, and there's Python library for Arrow, and there's R library for Arrow. And they both sort of interact with the low-level C++ API and give you access to it in your high-level language. But you have your own, library or your own library in your language that you interact with those. And they have slightly different things implemented at different times. So parts of the R library has stuff that the Python doesn't yet have right now, interestingly enough. And I'm sure it'll be added to the Python library later. An alternative is, if we look at the R Athena library that's in CRAN, the way it works is it uses Bodo 3, which is an interface into the AWS ecosystem for Python. And then it lays a reticulate on top of that. And then you use R on top of all that to basically get to the AWS tooling through reticulate Python, Bodo, AWS, and you can interact with some of the Athena tables and mount them as if they're a database connection. That's kind of an interesting model as well. So you'd end up not having a separate library for each. You use Reticulate to give you like the Bodo library, which is the Python way of talking to Amazon Web Services. It just lets R have access through Python. That's a different model. Also quite interesting. So we'll see these ecosystems develop both ways, I am sure. One thing you should know about if you're playing around in any of this world of stuff with AWS is you should know about the AWS Data Wrangler library, this Python library. It's data frame centric, so pandas for moving things around in the AWS ecosystem. Easy integration. I listed here Athena, Glue, Redshift, S3, a whole bunch of other junk in AWS. Those are kind of ones that I use a lot. If you've ever used any of this stuff and you thought, why can't I just read, some of this from S3 into a pandas data frame? Well, that's the kind of stuff the Data Wrangler does. Or if you say, oh, I wish I could just easily from Python copy this file to that bucket. Bodo 3 lets you do that, but it takes a few steps. AWS Data Wrangler lets you do that kind of with one assertive command. So you can say Bodo 3 is like a lower level API, while AWS Data Wrangler is a higher level API with more emphasis on ETL kind of work. So I recommend going checking that out if you're mucking around in this ecosystem with Python at all. So I haven't shown you any R code, and I'm not gonna, but we are going to open this up for questions. So I'm gonna stop sharing my screen. And Jared, you want to come on and do Q&A with me?
Yes. So the first question was, what brand beard shampoo do you use?
Beard shampoo. So let's see. I have my gym kit right over here. Now I just use whatever shampoo I'm using. Thank you for asking. But I do use a beard oil, or you get dry skin, and nobody wants to show up with beard dandruff. That's not a good look. Doesn't look classy.
I agree. Good to know. It's good to have these tips. In terms of your presentation, I'm not sure you actually said this or not. You said which method was the cheapest. Which was the fastest overall to make our whole run?
That's a good question. I don't have the answer right off the top of my head, but I believe that it was probably, it was one of the Spark methods where we could effectively put it on great big servers. So I think it probably was an EMR, or it may have been Spark directly on EC2. One of those two, but it was basically we could stand up a whole bunch of big machines. It was incredibly expensive, as opposed to like Athena was $1. This was something that was more like, $100 an hour. Now our job didn't take an hour, so we would pay fractional of that, but it was orders of magnitude more expensive.
So along those lines, you mentioned a big machine. Is 3 big machines better than 50 smaller machines?
Totally depends on your problem. This is where that uneven grouping thing, I didn't understand this when I started all this, but where we have this problem where a few of our classes, I call them groups, but our classes are really big. Our problem works best and it works easiest if during one of the steps you get everything from a class on one node. So if that node is not very big, I start spilling the disk or it just blows up. So this is one of the things we ran into in Dask is if the machine size was under provisioned, Dask blows up. If on Spark, if the machine size is under provisioned, it just thrashes to disk. So it slows down, but it doesn't just blow up, and it'll ultimately finish just kind of slow. So like they have very different failure modes if your node size is picked wrong, which is kind of like something you need to understand when you go through and do this. And so what we learned is at some point, as soon as we had a node size that was big enough that our least balanced group would fit completely on it, we were in pretty good shape. But if our nodes were too small, like our job just wouldn't run at all, or it would take just forever because of the thrashing the disk. Along with that is any of these, if you're just doing a one-off job, a bunch of this optimization doesn't matter. You're just trying to get something that runs, right? And that's fine. But if you're like going to have something, you're going to run this thing multiple times a day for years, pay somebody who's an expert on one of these platforms to help you read the execution plan and look at your performance metrics and understand what it does, because none of us can be experts in all this stuff. That's exactly what you should be throwing consulting dollars at. We were using consultants from Theorem, and in addition, got consultants from the individual platforms who had deep platforms specialists, with Dremio, with Coiled, or with Spark, to come in and like help us read our execution plans and make sure there wasn't some stupid mistake we were making that would make it like picking the wrong node size. Made sure that because it's not going to scream at you to do that. You got to look and read in the logs and realize, oh, we're thrashing the disk, or oh, we're spilling over out of our RAM, and that's a sign that we need to do this. That stuff, there's no easy button for that, in my opinion.
And is it possible to have different node sizes? Because why have just a bunch of giant ones? I like giant ones mix the medium and small ones, and different tasks intelligently go to the different parts.
There is nothing that manages that dynamically, in my opinion. Now, the way that gets implemented in practice is what tools like Dremio do is we have different size clusters that are based on different size machines, and it will create a query plan. And based on its anticipated size of the query plan, it'll route the job to a different queue, which runs on different node sizes. So in that regard, you're sort of doing what you say, but it's a fairly naive cut, right? It's just saying, oh, this is a long running query. We'll put it in the long running queue that has bigger nodes. This is a fast one. We'll put it, over here. And some of what that is like our queue for really long running stuff, we don't keep it standing up because it's expensive. So it times out after 30 minutes and shuts the nodes down. And so if I want to run a really big query, it's got to wait 5 or 10 minutes for that cluster to stand up, and then it runs and does its thing. And we're fine with that. But we just got to know that it's going to do that, as opposed to if we run a small query, we keep the small engine runs, during business hours. It's always running. And so there's no lag there. But none of the other systems that I interacted with do anything like that. And as a matter of fact, you have I pointed out that Glue, you have 2 or 3 node sizes. Similarly on Athena, it's completely serverless. You have no choice of node size at all. It just is sort of, you get executors. But you go over to EC2, you can choose your node size, but it's kind of up to you to figure it out. For every time you stand up a cluster, you got to make that choice. You can stand it up on different sizes, but it's up to the user to pick that right.
Okay. Continue along that round. By the way, folks, I have a bunch of questions here, but if you have more, put them in. We'll see which ones we get to. In fact, there is, this one didn't copy. It did. Okay, great. Let's see. Well, you talked about, this is just gonna be a joke that I had. You talked about Dremio and their data lake. How about their data lake house? Do they offer you that?
Oh, I know. Seriously. I have so much problem with these vendors because I just want to mock them for the naming, right? And that's not a healthy relationship with people that you're trying to have a professional ongoing relationship with. But I'm just about, but between, and it's like, just when I thought that was all ridiculous and I was kind of beginning to understand what they meant, people started introducing data fabric versus data mesh versus data Velcro. And then they started saying it's not ETLs, it's reverse ETL. And I'm like, I'm getting too old for this shit. Y'all just need to shut up.
Remember, Murdoch, he's always too old. He always went for it.
That's true. Yep. And it's like, I have lots of patience for the actual workflows, but the names that I think are nothing but marketing gimmicks are what I have no patience for. I'm like, tell me what problem you're solving and stop trying to come up with a cutesy ass name. I don't know. Let's see. I had a couple of questions here that let me respond to. One was about getting data into S3. A bunch of what we were doing takes place in S3. So the upstream process that generates it is already there. So when I do testing, I shove stuff in S3 using the AWS command line tools from Linux command prompt, or if I'm in Python, I use the AWS Data Wrangler tooling to copy stuff over to S3 buckets. One thing I don't know that's worth kind of commenting here. I'm not sure really where this fits in, but when it comes time to slurp data out of the cloud and maybe back to on-prem, some tooling will allow you to read in parallel through multiple nodes, and other tooling shoves it through one connection. Like anything that's got DBC on the end of it, for the most part, JDBC or ODBC is going to shove through a single node back to your database connection. I mean, that is what the standard, the DBC standards, my understanding is they don't have any concept of parallelization built into them. So they got to come through a single stream. But if you're using other tooling, it may read and write to and from S3 in parallel, which can be kind of nice, right? So you can fully saturate your home internet while your wife is watching TV. That's groovy.
Just don't take it down completely.
Right.
Eventually. So you have more questions, but there's one that seems sort of related to that.
Right.
Someone asked about bypassing corrupt Parquet files. How do you handle that?
Oh, that was the one about the corruption. Oh yeah, how do you bypass a corrupt Parquet file in Athena? Yeah, I've literally never had this problem, and that's not to say I just hadn't even thought about it because I've just never run into it. So I guess as soon as I have this problem, what I will do is I will go to my consultants who do a lot more cloud stuff at scale and ask them. And I am suspicious they will say to me something like, oh, then we switch to serial mode where we read the files one by one and figure out which one has a problem and skip it and then read all the others, right? I'm suspicious they have some fallback plan like that. I just haven't had a fight with it yet.
Well, John Keane and Neil Richardson are here, so just feel free to contact them directly.
Oh, fantastic.
Yeah, that's what I like to do. So Neil, John, you're under the bus now.
Cool. I'll call them as soon as I have that problem.
Exactly. You have any questions you noticed, and if there's something I'll go.
Walter asked about, I'm kind of avoiding this one about the server and clusterless approach. For example, TileDB, everything is an array. I haven't dealt with TileDB. As a matter of fact, I didn't even know that was a thing. Like, I don't even recognize the name. So I'm a little clueless there. One sort of, I should point out that the Dask library for Python, it has multiple, I'm not sure if APIs or ways of using it is the right thing. It has different abstractions. One abstraction is a data frame abstraction, and you relate to this distributed data frame as if it is one data frame, but in reality, different row chunks are on different machines, but you relate to it as if it's all one big thing. It also has a state for NumPy arrays. So you could do the same thing with a NumPy array. You don't have to think when you're coding it, which shard is on which work or anything. You're just relating to this one really big NumPy array. And then it also has effectively a parallel apply. So you can do an iterator, and it spreads those jobs of like doing the work of that across all the worker nodes. These are all Python abstractions, and that's 3 of the interfaces, and it's got at least 5. So I can't remember. Oh, there's one that's DAG. That's a DAG related construct. So it's got a number of different ways you relate to it. We found in the data frame abstraction, their shuffle algorithm is not as efficient as some shuffle algorithms. It's not awful. It's not bad. It's just our problem is really big, and we have 2 steps that basically demand a shuffle. And so we struggled a little bit with making Dask do well with our problem because of the needing to shuffle, and theirs not shuffling so well at this scale. Now, a lot of folks can do a lot of stuff with Dask and never see the problem we had. So once again, my experience does not transfer to everyone's problem, right? We looked at this, and we're looking at all these toolings in the context of the specific problem we were trying to solve.
And then Brian pointed out in the chat that Dirk Annabella was working on TileDB. And
Oh, okay. Well, it's probably awesome.
well, my first thought when I saw TileDB, it sounds a lot like SciDB, which Brian worked on. So
Yeah.
I don't know how close it is, but that's my first thought. Oh, this sounds a lot like SciDB. But yeah, so TileDB, and Dirk actually gave, I think, might have been a virtual use R, might have been something else, give a whole tutorial about using R with TileDB.
Okay, actually, I just opened up the website and I'm sorry, I have seen this. I just didn't recognize the name for some reason written down. I don't know if it's because it didn't have the little square brackets around tile, the way that they do it, but I have seen that. And if Dirk's working on it, it probably is fantastically performant, right? I mean, his whole background is with very, folks that don't know, he does the C++ libraries in R, and has a very high performance background. The stuff he makes tends to be like very fast. So it's probably done right, done fast, and something I need to learn more about.
And since Brian is in the chat, Brian, how similar is this to SciDB? I know that thing that I think Stonebreaker, you worked on a Stonebreaker a while ago. Because to me, I hear array-backed databases with an R interface. To me, they sound similar. So Brian, let us know in the chat, and at least for my own notification. Oh, similar. Great. Perfect. Thanks. Cool.
Ryan asked about if Athena could be set up for dealing with streaming data. I struggle a little with streaming data because everybody's definition of streaming data is kind of different. Usually what streaming data is just means rapidly updating small chunks of data. The whole Athena, as far as I understand it, when you run your query, it looks at Parquet files in S3 bucket. So if those are coming in some every second, it will deal with what's there. So if you are comfortable doing batches as your stream, which has to be Parquet files dropping off there, accumulate, that could be possible. But streaming in that context is not something I do. So it's not something I know very much about.
Streaming is Netflix for you.
Yeah, exactly. Streaming is what my parallel downloads from S3 break that my wife is doing.
There's a few questions, and this is one that there's some talk about price. But
yep.
You mentioned how dev time is more expensive than the tooling time, right? Yep. But cloud costs can really accelerate. And you mentioned before, you're doing this once, you're doing this 10 times a day. Where do you find that balance between developer and then also this thing's gonna be running thousands of times a year, how much that's gonna cost you? Where do you balance that?
Yeah, I mean, what we do is this is classic operations, right? So I would just do the math, right? Do the napkin. How much dev time do we think we're going to spend? Multiply that by 10 to get a correct number. And then that was a development time creep joke. And then you also just look at how many times you can use it and over what lifetime, right? So what do you think the lifetime of it? How many times a day? Over how many years? How does that add up? And yeah, absolutely. You can easily run into situations where the runtime, if you're running it 10 times a day, you got 250 work days in the year. That's 10 times a day. That's 2,500 times a year. If you can do it for $1 versus $10, you start to say, okay, I can pay a lot of developers on that kind of delta. But if you triangulate it and you're like, the expensive method costs $2,500 a year and the cheap method costs $1,200 a year, like I can't get a developer to get his head around my problem for $1,200 worth of development time, right? He doesn't understand my problem after he spent $2,500 worth of time, right? He's still trying to figure out where the bottleneck is. And so there's got to be a meaningful, tens of thousands of dollars of savings before you should really start, for example, building a whole internal architecture to make the problem faster. Now, I'm not talking about developer just to, build a little bit of something. I'm talking about if you got to build a whole bunch of plumbing to do a job, something that might take 2 weeks of developer time, be sure you need it.
Mm-hmm. There's a question. I think Paul asked this question in 2 places, so I think he really wants it asked.
Okay.
Is there a way to calculate the price performance of your alternatives you could have used to compare them?
Yeah. So the price for one, basically, how am I comparing the price of them? Is that what we're asking?
Yeah, I guess so, like without running it and building it, could you like speculate how much it would have cost? I guess that's what you're asking, like speculating how much it would have cost even without actually running through it.
Okay, so this is called bench racing, right? This is what mechanics do all the time. And I am of the opinion that when it comes to guys sitting around with highly linear systems without a bunch of feedback loops, you can do this pretty well. So my guys down at my local speed shop can compare a bored out 350 to a bog standard 454 and talk about the systems that were around them and tell you how those would perform in a drag race or something, right? They can do that because those are well-tested systems they understand. And so if you are doing a process that is well understood, the way that a small block Chevy is well understood in that community, you can do bench racing with your performance. My life experience says all of my problems do not fit that profile, and I got to actually run code. And the reason is there's too many surprises. There's too many like situations where, like we ran into with Dask, an example of we have 2 shuffles that we have to do. And they have like an alternative shuffling method, but it like, and I can't remember the exact deal, but like it only worked well if you only do 1 shuffle, but as soon as you have to do a second shuffle, it actually makes your second one slower. How in the hell, when you're bench racing this, do you ever understand and anticipate that? You can't, I'm convinced. So if you're really doing simple jobs and they match benchmarks and they're well understood, I think you can. I think otherwise, this is the importance of doing what I would call this minimum viable workflow or minimum viable data flow. You really got to test the bottlenecks in multiple systems because they're not super well understood. And your problem probably, if it's super simple and very symmetrical, well-shaped and well-behaved, you might be able to get away with that. But I highly recommend folks do testing stuff out. Now, this is, it's rampant empiricism, right? And he's basically saying, can we do this with a model instead of empirically testing? And I am a rampant empiricist. I think that we need to really do the testing.
Cool.
Okay, and I saw Paul say no, so he may have misunderstood.
Oh, all right. After you.
I wish I could just like phone Paul in here. So
How about your alternatives that you think some of the alternatives you could have used to compare them? So I'm not sure.
Yeah, I'm not sure I understand the question. I could keep guessing. I mean, after I built them, yes, I just run them and I look at the AWS cost and the runtime. So I'm missing something.
It's not the cost of what you could have built though. So.
That's true. That's true.
Well, Paul, I'm assuming this Paul Puglia. If you have more information, let us know. Or call me. I'll hold up the phone to
yeah. I wish we could just all go out and drink bourbon and actually, Paul, and talk about that. That's what I miss. So we will do that next time I'm in New York.
For those of you that are regulars when I was in person, Rye House closed. Yes, that was very hard on me. Luckily, Lily's down the street is still open, but Lily's, I love the Lily's, but Rye House, I see John just dropped in. That was a mainstay. I think when we were all a little too old for Lily's, so we were all going to Rye House, and it was great. And it's very, and everything's still, all the stools, I walk past it all the time. The stools are still there on top of the bar as if like they just closed up and left and never came back. It's
oh man,
it's been really sad. Yeah, that was a homey place. And even like the manager, Chun, I was texting him like, hey, what happened? It just, it's been bad. Yeah, Dusty just realized it's bad about Rye House. It's really sad.
So next time we're just all coming over to Jared's house.
Come on over. That's what we're doing. We got it. Yeah, absolutely. I do have enough bourbon around to make even JD happy.
Woo!
We'll get back to your questions in a second. Walter's asking what part of New York. That was Union Square. It's like 17th block away from Union Square. That's where we held a lot of the meetups. But a whole bunch of the meetups at different offices right around that area. We kept getting office space in that area. between Twitter, eBay, Pivotal, some other ones. We kept getting also Rye House was our home base for years. It was so good. Like they know we were coming. You tell them we're coming on Thursday night. They cleared a whole back room for all the nerds to hang out in.
It's pretty good. After one of the conferences, I brought my camera and got some really dope pictures in the back with I was using no flash and with my DSLR and got some really cool pictures.
One of my favorite pictures you took, and again, I think a lot of people will appreciate this, was of David Robinson, a starch tidyverse person, with Jeff Ryan of
That's
pure
exactly right.
tidyverse person. The two of them debating, and like it's like this medieval drama, the Renaissance drama in this photo that JD took. It was amazing.
It was, I saw that conversation going on. I just started snapping pictures. I'm like, this is bound to look interesting, especially if you know the people involved.
And I purposely scheduled their talks back to back because I wanted
That's great.
wanted them to go against each other. And so back to questions about this. Do you have any recommendations for intro reading on Athena and S3 for our users?
Oh, okay. So for Athena, it's much more straightforward. There's at least 3 packages. Well, there's 3 ways of connecting to Athena from R. So it's either use JDBC, use ODBC, or use the R Athena package that uses Reticulate and goes in through the Bodo 3 door. Good place to start is the R Athena package. They have at least a user manual and possibly a vignette. I'm not completely sure on that. That would be a good place to go peeking into it. With a lot of these tools, you kind of got to learn something about the tool, and then you learn how to connect R to it to use it, right? So it's not really like they're an immediate extension of R. It's more like it's a database and you're connecting R to it. Now, the neat thing, I have not used the R Athena library, so I'm not swearing by it or recommending it. But like even it's kind of neat because the one built on top of Reticulate still allows you to use your connection to Athena in a dbplyr workflow. So you can connect to it and pipe it through dplyr functions, and it does the right thing, right? Because it's a database. It acts like a database underneath it. And then you can have Athena just sitting on top of S3 files. So you're effectively querying Parquet files on S3 using dplyr is effectively what the experience should be if it all works. I have not tested it all out to make sure it all works. I've been trying to get other stuff going, but you got to get some point, like if you're going to use Athena, you got to go read an Athena doc. And the Amazon help files are pretty good. Their introduction to the tools, you got to read something there just to figure out what you're doing and figure out like, I've got these S3 files, how do I make them show up as a table? It's not hard, but at some point you got to read the docs to figure that out.
Then you might have said, but why was Glue the favorite for the devs? What made it so?
Okay. So what it was likable to them is it had a shorter learning curve than Dask did. Dask we had a lot of gotchas with Dask where we ultimately figured out how to do it, but there was real surprises along the way. And one of the surprises, and I was giving one of the Dask founders endless shit about this on Twitter, is if you have a great big Dask data frame that's spread across multiple machines, if you do a group by, its default behavior is to return the results. Well, you do a group by and an aggregate. When you do that aggregate after a group by, it will try to return whatever resulting records you have back to one node of the cluster by default. The hell? I got 7,000 groups and they're huge. That's terrible default behavior from my point of view. And because we would just like the very first thing we did was a group by and our cluster would fall over. And it's like, what? And it turns out like when we RTFM, there's a way to tell it how to spread that out across the cluster. But that's an example of we just kept stepping on our own cuff because of combination of immature technology and I would consider not real good defaults in a few places. And so we liked a bunch of stuff about Dask, but we found the getting somebody up to speed where they could actually be effective with it took like a developer focusing fully on that for a couple of weeks to work through all these hiccups. That's a long time just to get your head around, like try to make it work. The developers liked Glue because it was easy to get up and running. They felt like Spark was a little more robust for the type of workflows we were doing. Now, the thing we like about Dask is if you're in Python, you feel like you're using Python. When you're using Spark and you're in Python, you feel like you're remote controlling a JVM because you are. And so you get Java heap error messages back and stuff that are just like, what the hell? So that's a downside. But the combination of it was fast to get a good enough answer. Now, we spent some more time and got them faster as we figured out more things about partitioning and chunking the data. Even in Glue, we could make it faster, but it ran and didn't fall over before we got it fast. So they like that. And the whole hot cluster thing, the thing that you could ask for nodes and in 7 seconds, you could have 50 nodes. That's really neat. And you're billed by the second. So you can stand up 50 nodes, have them in 7 seconds, execute a job that takes 2 minutes, and tear that down, and you only pay for literally ever how many minutes it was stood up, and that's kind of nice. And it took less. It wasn't as fiddly as some of the solutions from the developer point of view.
Now, is Glue a lot more expensive to run than the alternatives because it comes up so fast and down?
More than the other Spark methodologies?
Mm-hmm.
I don't think that it is, but that you raise an interesting question.
Why would you just always use Glue instead of the other ones? I guess because
limited choice in node size, right? You got that three node sizes that I call two, because the smallest ones I thought were useless. So you only have 3 node sizes. And with the others, you can have and you can choose any kind of node size you want, like with one of the ones based on EC2. So if you use Elastic MapReduce, for example, you can choose any EC2 node size and use those. But you also then have to set all the switches to make it work the way you want it to do. And we are not, me nor my team are Spark specialists. So we liked in Glue that all the switches were a good set of defaults, because Amazon's picked stuff that works pretty well, right? And there's something to be said for letting someone with lots of experience pick your defaults for you.
Mm-hmm.
And they set those defaults to match the node size, right? So they're controlling the node size and they're controlling, so things just kind of worked pretty fast. That made the Glue pretty usable.
So we're going to do 2 more, I think. One just came in, and we have one that's been sitting around, which I will get to. Is it off topic a little bit from Walter here? Is there a way, has anyone know how to connect using R to a OLAP cube, specifically the Microsoft Analysis Server? JD, you already have an answer, it sounds like.
Yeah, so I tried to do this. What I've run into in our organization with, what is it? I think they got SQL Server Analytical Services or Analysis Services, the cube servers, colloquially known as cube servers. The problem that I ran into was the Kerberos authentication. And I do all of my analytics on Linux-based machines. And I think if you're on a Windows machine, there are libraries that make this easier. I never got it running because I was using Linux machines, and they're just one of our Linux gurus spent some time with it, and he's basically like, this is awful and hard and not good. How bad do you need this? And I had the job I was trying to run only needed to really be run a few times a quarter. So I created a process using the Microsoft tooling that would export would run a DAX job and export it as CSV into a shared file structure that I would then pick up with other tooling. So my experience is, if you run on Linux, it's awful. If you're running on Windows, I think there's a way you can do it, but I wasn't, so I don't know.
I know that we help customers all the time connect not to OLAP, but SQL Server via Kerberos from Linux. For they're using RStudio Server, and we can help them set up Kerberos to connect to SQL Server, all that great security authentication. I don't do it myself, but the people who work with me, they know how to do it. So it is definitely And they've gotten to the point where, at least for them, it's no longer a pain in the butt, because they've been doing it for multiple customers now. So be in touch.
I clearly need to hire Lander Analytics to
exactly. That's the message from here. That's what you need to do. Cool.
Yes, linked server. Walter mentioned linked server. That is a method. So you can link SQL Server to your analytical services and basically pass your DAX through SQL Server as a string. And that is absolutely something you can do. That's what my IT folks wanted me to do, and I had a great heartburn with doing that. But yeah,
it's a shame that we have to jump through all these hoops. We just want to write some equations down. That's all we're trying to do.
Well, everybody's mileage may vary with their organization, right? But I'm really trying to lobby hard for us to get away from, if we want to use cube servers as an in reporting for certain things, especially in accounting where they're sort of addicted to those and used to those, that's okay. The problem that I see it is if you have the business logic between the database and that reporting engine, if you have business logic in there and the result of that business logic is stored only in the cube, you've just painted yourself into a corner. And I think no organization in the year of our Lord 2021 should be doing that. If you put all your business logic in such a way that you apply that business logic and it ends up in a table in a database that's easily accessible from lots of different tooling, and then load from that table cached results into the cube, is, in my opinion, how it should be being done. Now, I know some of the stuff in our organization, they were trying to just get it into a cube because that's what the internal reporting folks said, that they just absolutely needed it there, and they built that for them. And then we quickly discovered, actually, we have other solutions that would benefit from that same data, but it was already painted into that cube corner. So taking a step back and solving it from the organizational point of view, we're beginning to think about putting more of that sort of stuff in Dremio. So in our data lake or lake house, or take our pants off and go skinny dip and whatever, I don't know what, there's a swimming analogy in here. And the idea is we'll do the business logic application of the business logic before it goes into Dremio. So the tabular data with all business logic applied is there in Dremio, able to be used by many different processes. Some that are automated like mine, but it may also be populated cube server because the accounting folks love those, and that's fine. I got no problem with that. It's just that getting us with logic, trapped logic, in effectively in a reporting solution is bad form.
Before the last question, I do want to point out you painted yourself in the corner of a room, and a room is just a giant cube.
Good point. Good point. Well taken.
So the last question we're going to do is, we've talked a lot about tooling and technology here, but remember this meetup is open statistical programming meetup. So we talk about statistics. Right. What was the purpose of this join of 55 billion rows against 100,000 rows, and what statistical process were you doing? Yeah.
So ultimately what we are heading for is understanding distributions. So ultimately, we think a lot about tails of distributions. So when things go bad, how do they go bad together? So a whole bunch of what we're ultimately looking at is trying to understand tails of loss distributions within a risk-taking organization, and that's kind of the big picture of what we were doing. Yeah, that's a good point. And I tried to make this all very generic because very few people have the exact problem I had there, but I think more people have, well, I've got big chunks of data, and I got big chunky data, and I want to do stuff with it, right? So we have a bunch of folks that are going to need to wrangle some data to do all kinds of different things with it, not just the stuff that I'm doing.
We do have more actuaries and insurance people at these meetups than even you might realize.
That's true.
Actuaries have been doing statistics for hundreds of years.
Yep.
So it's very
absolutely.
So yes. Okay, folks. So with that, we will let our agricultural economist head off. For those of you who don't know, JD is actually by training an actuarial economist. Right, is that the-
agricultural economist. So I work in the reinsurance industry, but my background is I have an undergrad and a master's degree in agricultural economics. I like to make the joke about agricultural economists being the OG data scientists because SAS came out of NC State, out of the agricultural program at NC State. And of course, it's a bit of a joke just because we have been tracking data in agriculture for thousands of years and trying to do statistics on it. You could also easily argue that physicists, with a bunch of the coding that they do around physics, measurements, and experimentation, they're the original data scientists, right? The actuaries may be the original data science. It's everything's, we've been doing this same sort of stuff across many fields for a while. It's just we didn't have it under one umbrella.
Now, a lot of people don't realize, like, Minitab came out of Penn State, an agricultural program, I believe.
I did not know that. I didn't know that it came out of an ag program, but yeah,
I think it did.
Penn State's the land grant University of Pennsylvania.
Yep, and a lot of these
Makes
land grant
sense.
universities, I think that's where Doug Bates did a lot of his multi-level models. I think that was based on, he wasn't agricultural himself, but was adjacent to agriculture people.
Mhm.
A lot of these methods were developed by either agriculturalists or gamblers.
Well, and brewing, right? So student t-test came out of Guinness. I encourage everybody who's in this field to read the book, The Lady Tasting Tea, which is the stories behind where did a bunch of our statistical tests came from. Like, what were the people doing when they came up with these and why did they do them? It's a great read. It's not a mathematical read.
Yeah.
It's an anecdote read.
With that, folks, I think we're going to call it a night. It's very late for some of you all around the world. I would like to thank JD for appearing again in this meetup where he's been a
Great to be here. Great to be here. Thank you so much for having me, Jared.
Thank you for being here. We always have a fun time with you here. This is going to be online shortly at nyhackguard.org and on our YouTube. Then someone's asking for the name of the book. Is The Lady's Tasting Tea?
The Lady Tasting Tea. So it's the story about the lady who said she could taste if the cream was put in and then the tea versus the tea and then the cream. And so it's basically like, how big of a sample size of that do you have to say that she can actually taste whether the cream was first or the tea was first? And this is some of the origins of, statistical tests, going back to the Victorian era. So that's what it's named after.
It's a classic book. Check it out.
Mhm.
And if you are in Dublin, which hopefully one day we're going to have our Dublin R conference, the Guinness tour, the warehouse tour, has a plaque to the inventor of the tea test right at the beginning of the tour. And they will let you take your pint of Guinness and go back to the beginning and take a picture of it. I know from experience.
Fantastic.
Yeah, it is really awesome. It's actually always rated one of the top attractions in Europe. Better than the Colosseum and Eiffel Tower. Seriously, check out the ratings.
That's awesome.
So, folks, the next month we have Max Kuhn. We have the R in Government Conference, December 8th, 9th, and 10th. We have in January, we have Disc.frame. In February we have DuckDB. We'll have other things coming as we announce them. If you want to speak, be in touch. We're planning a few months ahead right now, which is a really awesome problem to have. If you have office space, let us know because we want to come back in person. We need to get the space. And I hope everyone has a great rest of your day, nighttime, afternoon, wherever you are in the world. Enjoy the rest of whatever time you have left. And a big round of virtual applause that JD won't hear for this great talk. Thank you very much, JD.
Thank you all for having me. It was so great to see you, Jared, and great to interact a little bit. The part I hate is the lack of being able to see the faces in the audience and the going out for drinks afterwards and talking about a bunch of stuff. But I'm so glad that we could at least do this weak facsimile of the experience that we all miss. So great to see you, Jared.
Great seeing you too. It's always fun being around you. Hopefully I'll get to see you soon at some point.
All right, take care.